Hello. So today I want to do a short video that comes from Calc 2, Math 137 about the comparison theorem to determine if an improper integral converges or diverges. Now here's an example, very much like some of your homework problems. The question is, does this improper integral, the integral from 1 to infinity of 1 over the square root of x cubed plus 1 dx, converge? Now, you notice they're not asking what number it converges to if it converges, just does it converge, yes or no? Now, let's never forget what this symbol means. This symbol means the limit, as the upper limit b approaches infinity, of the integral from 1 to b of that same function. Now, the problem is that this is a non-elementary integral, okay? We don't know what function that is, so we can't evaluate the antiderivative at b minus the antiderivative at 1, okay? So what do? Well, we use the comparison theorem. So let me start with this. First, it's important when you use the comparison theorem that the integrand here, the number inside, I guess, right here, the number, the function inside is positive. I'm integrating from 1 to infinity of a positive function, so it will either converge or diverge to infinity. So, it's not 1, it's 0. So 0 is less than the integral from 1 to infinity of 1 over x cubed plus 1 inside the square root dx. Okay. Now the next thing you realize is, oh, if they didn't have this 1 in here, I'd have it made. I actually could find the antiderivative if I didn't have the 1 there. And so also that if I get rid of that 1, I've made the denominator bigger, right? Let's see, let me just write this. Okay, you go from 1 to infinity of 1 over x cubed without the 1 dx. Okay, so what am I saying here? I like to think of it this way. This has a bigger denominator than that. Same numerator, so this is smaller, okay? All right, same numerator, bigger denominator, smaller fraction, like 1/3 is less than 1/2. 1/3 is less than 1/2 if this thing was 2, okay. But this is equal to, it maybe looks a little bit funny, but we can write this just as x to a power. I have an equal sign here. This is 1 over x to the 3/2 dx, because raising a number to the 1/2 is the same as taking the square root. And then with this thing converges. I write less than infinity. What I mean is it converges since a, which is 3/2, is bigger than 1. Right? The integral from 1 to infinity of 1 over x to the a dx converges if a is bigger than 1. Right? It diverges if a equals 1. That's the logarithmic case. And for every other value of a, you can evaluate that by just using this definition, taking the antiderivative, blah, blah, blah. Okay, so we're basically done. This thing here is less than infinity. Okay, so the conclusion is that integral from 1 to infinity of 1 over x cubed plus 1 inside the square root dx converges by comparison to the convergent integral 1 to infinity 1 over x to the 3/2 dx. Okay? In fact, I could figure out what that number is, and I would know that it converges to some number, the limit, or the the value of this improper integral is something less than whatever this is, but doesn't really matter. The question is, does that integral converge? And also give a reason. Yes, that integral converges, and we know it converges because of the comparison theorem. All right. So, yeah, so these are actually pretty easy, but they do take some thinking. And I want to just reiterate the important step is like right here. Bigger denominator, smaller fraction. Okay. All right. Bye.